So welcome to the University of Adelaide's Electrical and Electronic Engineering 1A in-practice tutorial for Module 4, Part 2. Today we're going to be going through a short discussion on what to do if you run out of 470 ohm resistors. We're going to be showing you what other resistors can be used instead of the 470 ohms. Up here I've drawn myself an integrated circuit that has an output. This output pin is going through a resistor to limit the current and out through my LED, as is seen here. Now, a bit of background facts. The current that's needed to flow through an LED to turn it on has to vary between 5 milliamps and 30 milliamps. The lower current gives the LED a dull output, whilst 30 milliamps gives a very bright output across the LED. The other thing that we need to be aware of is the voltage drop across this LED is going to vary between 0.9 volts through to 3 volts. This is essentially due to the wavelength of the photons that are going to be emitted and the voltage drop that occurs inside the diode. So next we need to turn our attention to the voltage drops across this output of this integrated circuit. First thing we want to note is that this voltage before this resistor is approximately VCC, in this instance about 9 volts, and it's given by this equation here. So we can say VCC is going to equal the voltage drop across this resistor plus the voltage drop across this LED. I can rearrange this equation to get VR as a subject. So VR equals VCC minus VLED. For these two factors we know, VCC is 9 volts and the voltage drop across this LED is 1.5 volts because we're using a red LED and we discussed that earlier in the video. Next thing we want to do is rearrange Ohm's law because we now have the voltage and we know the current, so we get a subject of R. So R equals the voltage drop across the LED, which we've just found, divided by the current flowing through this LED, which has a range of 5 through to 30 milliamps. If we crunch these equations out, we're going to end up with values of value range of 300 through to 1500 ohms. These are the possible resistors that we've got to choose from in our E12 series that's supplied with the kit. Couple of last things to note, that if we're going to group an LED closely together in the form of a 7-segment display or the LED array that's going to be using in Module 5 as the final output dice, so that we want to use resistors that are roughly the same value, so they're going to have roughly the same current flowing through them, and hence we can have roughly the same brightness. Remember that current flowing through the diode is going to determine the amount of brightness. The more current, the more brightness. Also you should know, the more current you push through an LED, the shorter its lifetime. And conversely, the less current you push through an LED, the longer it will last. Thank you.